Alright, welcome to video number 4. And what I'm going to do now is stay with boot camp lesson number 3, continuous random variables in a normal distribution. But now I'm going to show you how to use NormsInv, the inverse standard normal function in Excel. So NormsInv. If you'll go to page 6 of the boot camp lesson 3 notes, I'm going to work through those 3 examples or applications and the one on page 7. Alright, so NormsInv. Alright, first application. Now all of these are going to use these same numbers. Suppose that the number of customers visiting a store each day is normally distributed with a mean of 278 and a standard deviation of 46. Number 1. There's a 25% probability, 1 chance in 4, that there will be fewer than what number of customers? Okay. Again, we're working with z distribution, so I'm going to find a z value first. Then I'm going to convert that back into an x value, a number of customers. These are x's. This has a mean of 278, not 0. It has a standard deviation of 46, not a standard deviation of 1. So this is x. I have to find z's from Excel though. Alright? And I want a 25% chance of having a value less than some z. So I'm going to put 25% in the lower tail of this distribution. Find what the z is. Let's go to Excel. In Excel, I'll use f of x, and this time statistical NormsInv. Let's go down to the ends. NormsInv. Make sure the S is in there. I want a lower tail probability. Remember, again, this is going to give you a description. Returns the inverse of the standard normal cumulative distribution. What's telling you it's giving it a number back instead of the probability. So you give it the probability 0.25. Do not put 25 in there. You'll get an error message. 0.25. Okay. That gives me a z value of minus 0.67449. That tells me that 25% of z's are less than 0.675. I have to convert that back into an x though. If you give your manager a z value, he's going to look at you funny. If your manager tells you, I want a 25% probability there will be fewer than what number of customers, and you come back with a z value, what's a z? You have to convert it back into an x. So, I want the x that corresponds to this z of 0.67449 negative. Alright, converting from a z value back into an x value, number of customers. Your x value is equal to the mean, 278, plus the z value of minus 0.67449 times the standard deviation of 46. So I'm 0.674 standard deviations below the mean. That gives me an x value of 246. In other words, this x value, 246. So go back to your manager and say, there's a 25% probability that there will be less than 246 customers today. Application number 2. If we can find it. Application number 2. Aha. There's a 75% probability that there will be fewer than what number of customers. Well, 75% is going to be on the upper end of the distribution, isn't it? Because there's 50% in each end. 75% will be fewer than what number of customers? Well, Again, I'm going to find a Z value from NormsInv. Then I want to convert that back into an X value with a mean of 278. All right? So I'm going to find the Z from NormsInv, then convert that back into realistic numbers, interpretable numbers, X. All right? We're going to plug then 75% into NormsInv. Now, you can go through all the steps again, or you can notice up here in your formula bar, NormsInv is already there because that's what we just used. Why don't you just plug in 0.75 in place of the 0.25, hit enter, and you'll get a probability of 0.67449. In other words, 75% of Z values are less than 0.67449. Let's go back to our problem. I know then that this Z is 0.67449. Remember, your manager doesn't want a Z value. You don't want a Z value. You want a number of customers. You want an X value. So I need to convert that Z back into an X. How do I do that? Same as before. Use the formula. I'm going to take my mean of 278 and then add the Z value of this time positive 0.67449 times the standard deviation of 46. And I'll come up with 309. So your conclusion, there's a 75% probability that there will be less than 309 customers on any given day. And that's application number 2. Moving on. Let's go to application number 3. Application number 3 says, using the same setup, a mean of 278, standard deviation of 46, there is a 20% probability that there will be more than what number of customers. Well, we've played this game before. We have to convert it into a Z, so I want a Z value, and I want this upper tail. So there's 20% chance of getting a Z greater than this value. Problem is, Excel gives us lower tail values, doesn't it? So, how do I do it? An upper tail value of 20%, there's a couple ways I could do it. One of the easiest is to say, look, if there's 20% in this upper end, there must be 80% down here in the lower end. That's one way to do it. Let's find NormsInv with a probability of 80%. 80% less than Z then will be equivalent to 20% greater than Z. Let's go to NormsInv. Now again, since I already have pulled this up in Excel, all I need is a NormsInv for 0.8. 80% or less than what value? Let's find out. 0.8416. So 80% of Z's are less than, in other words, 20% of Z's are greater than 0.8416. Let's go back to our math. How do we convert a Z value of 0.8416 into an X? 278 plus the 0.8416 times the standard deviation, and we get 317. Your conclusion then is there is a 20% chance that your daily number of customers will be greater than 317. And that's application number 3. Moving on. The last application is number 4, and it asks you a little tougher problem. It says, look, There's a 90% probability that the number of customers will lie within what two values symmetric around the mean? What does that look like? Well, in terms of a z, it means we're going to put 10% in the two tails. I want 5% in each tail since it's symmetric. So I'm going to put 5% in the upper tail, find that z, put 5% in the lower tail, find the negative z. The two together then add up to the 10% in the tails, 90% remaining between those two values. So 90% between the two symmetric z's, plus and minus, means I'm putting 5% probability in each tail. Well, that's easy with NormsInv. I just look for the negative z with 5% in the lower tail. Let's go to NormsInv. And again, since I already have it pulled up, I'm only going to put 5%. Don't go 0.5, that's 50%, guys. Go 0.05, 5% in the lower tail. Hit enter, and you'll get a minus z of minus 1.64485. Since this is symmetric, then the positive z will be plus 1.64485. Going back to my math, that means this is minus 1.644, this is plus 1.644. I don't want z values though. I need to convert those into x's. Customers centered at 278. To do that, let's do a little calculation. The lower value is going to be the 278 minus 1.644 times 46, 202 customers. The upper value will be 278 plus the 1.644 times 46, or 354. So what you will conclude, looking at our diagram down here, is that 90% of the time your daily customers will be between 202 and 354. Or restated, on 90% of days, your number of customers will lie between 202 and 354.